Hi all, good morning. As part of Hackathon 2025 challenge, we have opted for the theme AI-driven hyper personalization and recommendations. My team name is Stealthminds, and the application that we have built, we named it as No More Guesswork AI-powered personalization. Coming to the process flow at a very high level, so it looks something like this. So we first installed all the dependencies, all the required packages and libraries, and given the problem statement, we wanted to keep the data set as close as possible to the as specific as possible to the banking domain. So we generated some synthetic data using the template structure that was shared with the problem statement, and then we performed data pre-processing for both basically for the multimodal data, structured and unstructured data, and then we stored the results of the embeddings in a vector database like FIAS, and we developed the model, which is the actual recommendation model using RAG. So the model that we used is Mistral, and once the model is trained, we used we created a front-end application using Streamlight package, and then we also ensured we did this ethical checks and benchmarking. So it's at a very high level. This is the process flow. Now I'll move to the actual demo of the application. So yeah, once we launch the actual application, it looks like this. It's a Streamlight based application. So we have three different data sets with us. One is the customers data, the which has some basic details about the customers like customer ID, age, gender, location, and stuff. And then we have social media related information about that particular user. And also we have the transaction related details of the particular customer. So with that, we have trained the model. So we already have the customer data with us. So we have given a drop down option to select the customer ID. For example, by default, it selected the first customer ID. The moment the profile is selected, it gives some basic information like what are the details which are available from the database, and then some demographic context like the user is a female, 32 years old, and it's below median income. So basically, it is comparing with the median income of the entire data set. And then when we click on the generate recommendations, so it loads the LLM model that we trained, which is the Mistral model, and it tries to give it analyzes the profile, and it tries to give the financial related suggestions and recommendations. So I'll show this will take some time as the model gets loaded for the first time. But once the model is loaded, the subsequent customer recommendations doesn't take that much of time. So I'll show a simple response of how it looks like. So I have this user, and the recommendation that it got generated is this. So we have opted to select, instance, we ask the model to give top three recommendations for the particular user. So the results are pretty decent because we trained with Mistral, and which has around 7 billion parameters. And initially, when we started, we did it with GPT-2. The results were a bit noisy. So that's when we decided to move to the Mistral. So this is a sample response recommendations which the model is giving to the user based on the income, the recent spends. So this is purely generated by the model based on the information of the particular user. And also it gives the fairness of the entire data in sense like whether the data is biased with respect to the gender, or if the data is biased with respect to the income groups. So we want to ensure that the model is not biased. And once this the recommendation comes up, you can also look at the performance. So we have four different parameters like the collaborative filtering of RMSE, which is root mean square error, MAE, which is mean absolute error, baseline predictions, and patterns captured. So we did the entire recommendation generation using very limited data set because we had to artificially create the data. So these RMSE values and the metrics can be definitely optimized uh, by performing a few more operations, or maybe scaling the data, normalizing on the EDA part of it. So there is definitely a scope of improving the performance of this the results. And coming to the process flow, the coding side of it. So initially we started with the EDA, So EDA is like we installed all the dependencies and then we generated the synthetic data. So we generate, as I mentioned, we generated three different files. One is the customer data and social media data and the transaction data. So customer data will have this kind of details like customer ID, age, gender, location, interests. And social media data is like about the sentiment scores and the content about what they think about particular product they purchased or a given particular product. And also we have the transaction data, the recent transactions of the particular user. And then we did data pre-processing. So we stored the data using in CSV format, and then we reloaded the data, and we performed the sentiment scores, sentiment analysis on the content, and also on the customer ID. Like the same customer can have multiple transactions. So we grouped on the customer ID to get the mean and the sum of the entire amount spent. Basically, this is to get the average spend and the total spend. And then we did this multimodal feature engineering. So where we leveraged, initially we started with distill bird model. So distill bird based uncased, and then we did the embeddings, and we stored those embeddings in FIAS vector database. But Distilbert was not very was not giving very good results. So then we decided to move to the all MPNet base V2, which is a very good model for the sentient transformers. And then we tried with a few prompts like recommend a financial products for this particular customer, right? And initially when we started, we trained the model using GPT-2, and the results were a bit noisy. So if you see the response, the results are not very great. So in sense, there was a lot of noise in the response from GPT-2. That's when we decided to go to the Mistral model. So again, so using Mistral, we so the all the pre-processing steps remain same. So we loaded the models. We already had this synthetic data. So we leveraged that synthetic data that we generated, and then yeah, the sentiment scores and the aggregations remain same. So here is where doing the actual AI recommendation system. So we are loading the LLM model. So the model that we chose is Mistral, which is and version 2, because version 3 is a bit heavier than this. And also we define the pipeline, the tokenizer and the max new tokens. The reason why we use 256 is because of the optimization reasons. It was taking longer time when we increased the max new tokens. And also this model struggled a bit to display the results when we didn't have the quantization. So we brought in this quantization as part of the hyperparameter tuning and optimization. So we used 4-bit quantization model here, and then we are generating the recommendations using this particular function for this particular given this particular user, the age, income, recent spends and interest and social sentiments. We are asking the model to generate three financial products, and we also performed the bias check, which is the bias detection, whether the model is biased with respect to the gender or biased with respect to the income groups. And benchmarking is basically to check how well the model is performing. So as I mentioned, there is definitely a scope of improving the model performance by adding the steps like scaling and normalization in the pre-processing. And then we expose the entire thing as an Streamlit UI. So this is for the Streamlit part of it. And then to execute that, we will need this. We created a local tunnel and we are executing that, and it generates this particular URL. So this is the URL which it generates. And so yes, as I mentioned, you can select the different customers. For example, maybe I'll pick some other customer. The moment you select a different customer, the values gets refreshed here, and you can use generate recommendations again. And if you see the right hand part of it, the ethical metrics and performance, basically this is at the entire data set level. It's not particularly for the user level. So this ethical metrics and performance is for the entire data set as well as the ethical metrics. So if you would have noticed, the recommendation which was there before versus now has changed. It's purely on the basis of the income and the recent spends. Uh, that's pretty much. Thank you.